happen to the lions if there's no antelope? What would happen? Would they just switch to eating grass?
Die.
They're going to die. What happens if there were too many antelope? What would happen?
They would starve.
Right. They would starve. Why? What's the mechanism?
Grass.
The grass, right? What happens if there's too many of these? What happens?
Nothing for this heart.
There's nothing here, right? What's going to happen to this? It's going to blow up. Everybody always says, oh, well, my pond is green and all I have are a bunch of bluegills in it that are this big. It's the same thing as saying, or the same thing that would happen on the African plains. Exactly the same. I love this graph. And when you think about it, it makes sense too, right? What happens if all those things aren't interacting right? Something's going to be out of whack. Yeah.
Where does depth play into this? I mean, the sunlight's coming from above.
Yeah.
And so, like, say, catfish or bottom
Sure.
feeders.
Sure.
How do they factor into this?
Yeah. So catfish really in small ponds, and I'll talk about this briefly, but catfish really don't have any effect. There have been hundreds and hundreds of studies by some very famous fisheries scientists that look at the effects of particularly channel catfish. We don't want to put flatheads or blue catfish in our ponds. But their effects are minimal. They're going to be consuming different things. So you can rest assured that putting some channel catfish in your pond, they're not going to be consuming your bluegills. They're not really an active predator like a bass.
So you can fish them out though too, right?
Yeah, you can. And so every one of them that you harvest, you have to put one back in. Because
do they reproduce? They don't reproduce.
they don't reproduce in ponds. Well, now, remember we can never say that in science, that something can't. But we say that at least to date, there is very minimal evidence that channel catfish spawn in ponds. Got to have some flow. I have one graduate student now that is he's a supervisory fishery biologist in Indiana. And what he's doing in his ponds, he's trying to create channel catfish to reproduce. And what he's doing is he's making boxes. He's putting these boxes made out of, I think, 1x12s, just making basically, these little boxes for the channel catfish to swim in. And he's actually had fish spawn in those boxes, and he can get the larvae, but then the next year, all of those larvae are gone. And I think we came to terms that the largemouth bass are just mowing them down. Yeah. So anyway.
Now, what in the containment pond theory, where you're cleaning and you've got greater movement of water.
Sure.
Would that be better to have them in there?
I don't know. I think your turnover in that pond is too fast. I think it is. I think it's too fast. Yeah. Any other questions? Cool. But anyway, when you think about your pond, I want you to think about all of these things. Now, remember what we said. If we had too many of these, we're going to lose all of this. This is going to go up. What's going to happen to our aquatic vegetation? All those beautiful plants that we have in our pond. It's going to go down. Why? Because now the sunlight can't penetrate deep enough to get to those aquatic plants. So then the whole cycle is a thing. So what would be the best way to reduce those?
Eat them.
Yes. Right? Eat them. Or what else could you do? What's another? This is all what we're talking about right now in the science world is called biomanipulation. Biomanipulation is basically the study or the process of altering the biomass of each one of these different trophic levels and determining what the effects will be on the remaining trophic levels. There's something called a bottom-up trophic cascade, and there's something called a top-down trophic cascade. A bottom-up would be influencing the amount of algae. It's going to have a bottom-up effect on the aquatic ecosystem and the critters that are there. And if you manipulate the top end of the food web, that's the top-down trophic cascade and the effects that it's going to have on the food web. So it's kind of cool.
So you want algae?
Yes, algae's, everybody's like, ooh, I don't like seaweed. It's like, look, you need this. This is a thing. You have to have it because it plays an integral role in how that system operates.
And then ideas to control.
Yeah. You got to control everything.
So
how you control everything, this is super hard to control. This is super hard to control. So what you can do is you can manipulate this. How do we manipulate this? Well, the first thing that we need to do is we need to control the amount of sedimentation, erosion, nitrogen, and phosphorus that are coming in. Because if you have too much sunlight, too much nutrients, then you're going to blow this up, right? So you have to control that, right? The other way that we can control this is we can think about it from a top-down perspective. If we have the proper balance of these two trophic levels, which are very easy to manipulate, that's going to have a top-down effect on what this part of my food web is doing. This is where I come in. Anyway, it's cool. Yes, sir.
When would you use or would you use a pond aerator?
When would I use one? You have to be very careful with aeration in ponds. If I was trying to increase the amount of biomass that my pond could sustain, that's the time that I would use it.
So do you recommend it?
No.
Okay.
What about like a solar mister and you want to attract hummingbirds?
Sure. Whatever. That's outside of that game. But yeah, I mean that'd be good. I think the way I think about ponds is that just as the gentleman had to leave for a second, I always try to keep it as natural as possible. And Steve, relating to your question, I think the reason that people add aeration systems to their pond is, again, it's like a Band-Aid for something else that's going on. So anything that you're having to do in access or in addition to maintaining this, you're doing it for some other reason. Something else in that pond is not doing what it's supposed to be doing.
And is that true of ponds that, like you and I were talking about, very small ponds?
Absolutely.
Okay.
It's exactly the same. If you don't control the amount of nitrogen and phosphorus, if you mow or water your lawn, and that water had, and maybe your husband or whatever, he put fertilizer on it. That goes in, well, good. But maybe your neighbor did, and somehow you're downstream of your neighbor.
We're on the top.
Oh, that's right. That's right.
Yeah.
Anyway, I think a lot of times, and this is a good thing that it's taken me a long time to realize, is that ponds. Everybody wants to just think that, well, if I just throw some stuff in there, then everything is going to be hunky-dory. And the fact of the matter is that ponds are very complicated ecosystems, and we really have to understand all of the processes that are influencing the pond simultaneously. So it's not as simple as it looks. There are people that spend their entire careers, or have spent their entire careers, understanding how all of these things sort of fit together. So it's not simple. And if you get one thing from today, know that our job as pond managers is really difficult. And we have to think about a lot of things simultaneously. Yeah. Anyway. This is the base end of that food web we were just talking about, phytoplankton. Creates oxygen. If you have too much, you get green water. It's the basis of the food web. This is, well, what does algae smell like? It stinks. Okay? So you can see, that's not a very great picture, but you can see that that pond is a bit green. There are some other harmful kinds of bacteria or plankton that I'm going to talk about. Blue greens, those can be problematic. Anyway, there's a balance here too. Just as we talked about the balance with everything. You have too much algae, you're going to have very few aquatic plants because the sunlight can't penetrate. If you have overly clear water, you're going to have a lot of aquatic plants and very few or very little algae. Yes?
Lily pads, where do those fit into this?
Yeah, they're aquatic fish. They're great. They're wonderful. Again, they act as that. So prevent that sunlight penetration. Also creates a thermal refugia below it because it gives it a little shade. It's like sitting below a tree. You know? Until you get too many of them. Because too many is not good. Right? Because then what you've done is that once you cover the top of the pond, now sunlight can't penetrate. Then any of the other aquatic plants that are there, they're going to start dying back, using up oxygen. Next thing you know, you have a fish kill.
What are the top needs that need to be met to create a pond that is good for swimming?
Yeah, I worked on a pond in southern Illinois, and the landowner, he wanted to create a pond for his kids to fish and all that. But anyway, his wife, which she wore the pants anyway. Anyway, she said to me, he and I are having this discussion. She said, look, all I want to be able to do is swim in this pond. That is the #1 priority. Okay. So what we did in that pond, this was actually really cool, is that I still had the conversation with the gentleman that was there, and I said he wanted to fish. And I said, well, why don't we create area about 10 or 15 feet long that your wife could, walk out onto and then go do her swimming. And he says, oh, that sounds like a good plan. What we did is we took that fabric that you put in your gardens, you know what I'm talking about, to prevent the weeds from growing up, and then we took about 1,000 pounds of gravel. And we had good aquatic vegetation all established all the way around the pond, and his wife didn't like it. So what we did is we took that fabric cloth or whatever, and we put it on the bottom, and then what we did is we shoveled gravel on top of it, and then what it did is it prevented aquatic vegetation from growing in that one specific location of the pond. A cool side thing happened though is that's where all the bluegills spawned. So that was kind of neat. Real small gravel. We use really small gravel, and you want to use a lot of it to prevent that aquatic vegetation from being able to come back up through there. So, yeah.
She get nibbled by the.
Oh yeah. Oh yeah. Yeah.
Still get nibbled.
Yeah. And she was very happy that we were able to come up with a compromise there. It took a lot of head scratching to figure that out. So, I don't think that you really need to. I don't think that you need to really worry about too much, other than runoff being impactful to swimming. So, if you're in an area that maybe there's a lot of insecticides, herbicides, any of that stuff that's being used in the watershed, then you go out there and drink that water. It may or may not be good for you.
Well, I mean, E. coli and...
Yeah, I mean, any of the runoff stuff, yeah. It's a watershed thing, so, yes.
When you get this algae overgrowth and start turning yellow and looking like scum.
Yeah.
Copper products.
Yeah, copper sulfate.
Any adverse effects to that?
Yeah, so there are. So again, this is a living, breathing organism. And let's say that you have an algae problem across your whole pond. You go and you spray it and kill all that algae. What happens next? It's an aerobic process. As soon as you kill all of that life, as it degrades, it decomposes, uses up oxygen. As it uses up oxygen, there's less left to your fish. Eventually, if you kill too much at one time, you'll end up killing all your fish.
There's this blue solution.
Oh yeah, and I hate that stuff.
Tell me about, because it changes the color.
Yeah, I think
Changes the light.
it looks weird. It's unnatural. It gives me EBGBs.
It's supposed to be non-toxic to fish or plant.
It isn't, but it looks terrible. It's unnatural. And I'm sorry I'm letting my personal feelings come out here. If you have a blue pond, well, sorry for you.
Well, what is it?
So what it is, it's a Band-Aid for what you're doing wrong. That's what it is. It's very much like Steve said. It's the aeration. What it's used to do is it's used to prevent excess algae. And so when you have excess algae, why do you have excess algae? I always ask the landowner that question. Why do you have that? Well, I fertilize my grass and every 2 days, and then I water my lawn 12 times a day, and then it all goes in my pond.
Well, we
That's like one out.
but we don't. It's not where any fertilization drains into it. It's coming out of the woods. But it's usually on only hot summer days where there's not too much flow, but the algae starts, building up and start collecting around the rim of the perimeter.
Mm-hmm. Is it an access?
What do you mean?
I'm saying, is it problematic?
Well, we don't know enough to know that out.
Well, see, so that's the other thing, is that sometimes our human perception of a problem relative to the biological perception is much different. The needs of our fish and all these different levels of the food web that we talked about, maybe it's problematic to your eyes, but to the fish, it's actually a really good environment. Does that make sense? I don't know.
Yeah, I guess that is, more.
I say let's manipulate the top end of the food web, the bass and the bluegills. Let's get that ratio right, and then let's ask the question: should I use blue
That's what
dye?
I want to know about the top end. Well,
Yes,
well,
I think you can.
With minnows fitting. You don't have minnows in those, but we were told to put minnows in.
Right, and that's another thing I don't like. I don't like 3 things I don't like. I don't like minnows. I don't like grass carp, and I don't like blue shade. Those 3 things are not good for ponds. I think that
But you have the zooplankton
Yes.
to deal with the algae.
yes,
So
that's a natural. My natural man is back.
Yes.
So anyway, the way that I would control the algae is through
Hold
zooplankton,
on just a minute.
and I control the algae by preventing excess sedimentation, excess runoff from coming into my pond with the riparian buffer, even though it's not a riparian buffer. We need to come up with, you and I could coin a term for that. Lacarian buffer. All right. Okay. Yeah, don't use blue dye. Don't use. So again, those 3 things: minnows. Minnows are a Band-Aid. Grass carp are a Band-Aid, and blue shade is another Band-Aid. Those are just Band-Aids.
So grass carp could actually create an imbalance.
Yeah, absolutely. Think about that. If we're trying to balance the needs of having aquatic vegetation as structure, and then we have algae in our pond, and then we put in a grass carp, and it consumes all of our aquatic vegetation. Now what's going to happen is that those nutrients that were being used by the aquatic vegetation are now going to be used by the algae. Then what's going to happen is that we're going to have excess algae. When you have excess algae, you're going to prevent sunlight penetration, and then it's even going to reduce plant growth even further. So.
Well, how do you know
Yes.
when it's out of control, your algae? What are the warning signs?
I say that you go out there and you do some fishing and you figure out if you have the proper balance between predator and prey. Remember, as I was saying, we can use fish as an environmental indicator for everything else that's going on in the watershed. And most of the time, if that ratio is in balance, there's not any other problems with the system. That's why I like to use fish. Fish are easy to catch. It's easy to look at. And if those are in balance, then the other issues within the system, if there are other issues in the system.
Well, in our pond, we got a lot of fish. We got nice populations of bass,
Okay.
bluegill. There's some crappie in there. But we also have a lot of algae. in the summertime when it gets warmer.
right?
So, are you saying that's not a problem, or?
No,
It's just maybe visually we don't like it, or it gets on our fishing hooks and.
That's right. I think a lot of times we want the perfectly manicured pond, and like I said today, or the title of my talk today is creating the perfect pond. We're not talking about creating the perfect pond for you, your eyeballs. We're talking about creating the perfect pond for the organisms that interact in that environment. So even though it may not be manicured and weed-eated all the way up to the edge, it's acting like a very much a natural system in that each one of the levels of the food web are interacting to sort of make that ecosystem what it is. So, and you know what? And I'm not picking on you, but a lot of times our views of what's good and we have a good fish population and all those things. And I do this too. So that's what I'm saying. I'm not picking on you. But I think a lot of times our view of what's good or what's a lot of fish in a pond really might be clouded with respect to a scientific understanding of what's going on in the pond. So anyway, yeah.
I missed it. Would you define green water?
Yeah. So this is green water. It's just something. All I'm saying there is there's too much algae growth, and that creates that green environment, and it stinks.
So another question about green water.
Yeah.
On freshwater stream, after we have a rain event, the water's muddy.
Yeah.
It starts to recede.
Right.
It turns green.
Yes.
Before it starts to clear.
Yes.
Now, is that green?
That green is exactly that green that we just
Okay.
talked about.
Okay.
So what we did is we brought in all this soil that was full of nitrogen and phosphorus. The stream starts to slow down. Those nutrients can get into the pockets where it can actually be utilized by the organisms that are there, the algae, whatever. It grows up, and then what happens is that eventually those nutrients are washed out, and that's when we end up with our clear stream again. So yeah, very good. That was a very good point. Make sure I'm still plugged in. Yep. Oh, I got to talk about that. Oops. This is that intermediate level. If we want to manipulate the amount of algae in our pond, this is one way that we can do that. Zooplankton are very important. They're those tiny microscopic animals that are going to be consuming that algae. And then they're also important for our bluegills that are present in the pond, right? Or whatever that intermediate level is right before our top hit predator. This is also a very important thing. These microscopic animals, they're used by all of the larvae that hatch in your pond. So if you see little bluegills or little bass in your pond, they have to have a food resource. This is their food resource. Very nutritious. What's that?
Can you buy that?
Nope. You have to manipulate your pond to create the environment that's good for this. This is just a thing that happens. It's like when you open up the door on your refrigerator and the light comes on. That just happens. It's the same thing. Nobody knows how that happens, but it does.
Is this the time to talk about mosquito larvae and issues about, we don't want mosquitoes and
Sure.
the diseases they produce?
Sure. So Susan, which is she was a naturalist in Missouri. I created a pond for her in her backyard, and she was so worried that she was going to have mosquito problems. And I told her, I said, "How do you think we can get rid of those?" "Well, we just don't have any water." No, that's not the solution. The solution is to have something that will consume mosquito larvae. What consumes mosquito larvae? Fish. Bluegills. All of these things that could take advantage of that resource. And so what we did in Susan's pond is we had plenty of bluegills in there that would take care of all those mosquito larvae. It was crazy. Even though she had a wetted backyard, the number of mosquitoes that were back there, you could go back and set by the fire, and you wouldn't have any issues with mosquitoes. Some. You still have to spray on, but it wasn't as bad as setting in a yard that didn't have, mosquito or a pond, stagnant water. Anyway, yeah, cool.
So the pond water doesn't have enough
Yeah.
to keep mosquitoes?
Well, and the other problem is that where you see mosquito larvae are in those areas where there's no predators. There's nothing to consume them.
And the water's pretty still.
Yeah, and the water's still. So if you keep that water flowing, whether that's wind and wave action, natural, or you, in the case of Susan, we had a recirculating system in there that allowed the water to keep going. Yes, sir.
So starting from scratch, then you do some stocking?
Yeah. So stocking is important, and so
What numbers?
yeah. So
How-
the specific number. What we want to do is in the fall, for every acre of water, we stock 300 bluegills in the fall. Okay, early fall.
Every year.
Nope, one time, that's it. We're stocking those bluegills at 2 to 4 inches. And then we're giving those bluegills that entire fall to get accustomed or acclimated to your pond. And then we allow them to overwinter in our pond. Again, give them some more time. And then the next fall, we're going to stock 6 to 8 inch largemouth bass. Now what that's going to allow to happen is that our bluegills are going to have some time to grow. Maybe they're now to 5 to 7 inches. The bass are only going to be 6 to 8. They're not going to be able to eat those. They're not going to be able to eat those bluegills. But the good thing is that now that the bluegills are of that size, they're the size at maturity. Now those bluegills will begin to spawn, and then those small bass will be able to take care of those very small bluegill larvae.
How many bass?
100 bass
Per acre.
per acre. Per acre.
One time.
One time. That's it.
And do you just stop there with that diversity of fish?
If that's what you want. I don't.
What about lake trout?
Lake trout?
Yeah.
In
char.
West Virginia.
Char. I mean,
Oh, yeah, well, in the wintertime you can stock them. Yeah, but in the summer they're gonna die. They're gonna die. Yes,
You can put catfish in with
Yeah.
fish with no effect.
25 catfish per acre. And then you can put them in whatever size you want to. No blue cats and no flatheads. Yes,
This is gonna be a naive question, I
Uh-huh.
guess, but when you say acre of pond, are you talking about surface?
I'm talking about surface acre. Yeah,
Well, when we put, and we were told to put koi in.
yeah,
Now, we have about 4 to 5 koi per about a quarter to a third acre pond.
that's fine.
What's your feeling about,
Koi are fine. Koi are not doing anything. Koi are just there for people to look at and make their eyeballs happy. That's
aren't
it.
they keeping some of the bottom clean or anything like that?
No, they're going to be picking off aquatic insects. The problem with koi or carp, because everybody wants to put lipstick on a pig, right? It's still carp, just so everybody knows. A koi is a carp. Anyway, we have fancy terms for them. The problem is that if you have too many koi in a pond, they have the tendency to feed on the bottom, okay? When you feed on the bottom, you're stirring up those bottom sediments. What happens when you stir up those bottom sediments? You prevent sunlight penetration. When you prevent sunlight penetration, eventually what happens is that your aquatic vegetation begins to die back. Your algae is going to go up because now your rooted aquatic plants are not going to take advantage of that.
What about hybrid bluegills?
That's another thing I don't like. I don't like that word either. I don't even know what that means. Hybrid bluegill is a term for typically a green sunfish crossed with a bluegill. And so what happens is that you have this hybrid vigor thing that goes on, and that's for the first generation, right? You have this thing called the hybrid vigor, first generation, that my hybrid bluegills grow to these massive sizes, which that's fine. But then as soon as those die out, or as soon as they start to reproduce, even though hybrids can reproduce, right? False, they can.
Oh, yeah, okay.
Anyway, now you take two of these hybrids, you put them in the same spot, what do you get? What progeny do you get? Who knows? You may have a 1/3 bluegill to a 2/3 green sunfish. Eventually what happens is that hybrid vigor goes away, and then you end up with a bunch of green sunfish and a bunch of bluegills. So don't do that. Don't stock hybrids. When people say copper nose, whatever, you don't want that. You want bluegills and bass. Micropterus salmoides, Lepomis macrochirus. Nothing else. Ictalurus punctatus. Yes.
What's a red ear?
A red ear. Red ear's a good one too. Red ears are another sunfish. They can be stocked with those. Remember how we were saying that ratio 100 to 300? You could put in 100. You could do 100 red ears and 200 bluegills. Red ears are really cool because has anybody ever heard of white grub or yellow grub disease or black spot disease? When you fillet a bluegill, who's filleted a bluegill that had little black spots in it? Anybody fishing here? Have you ever caught a bluegill that had black
seen that on
or yellow grubs in it? Nobody's ever seen that before?
I've seen it in bass.
Yeah, in bass. It happens in bass too. Right. So what's going on there is there's a super complicated life cycle with wading birds, with a snail, and fish. And what happens is that the intermediate host, which is the snail will then be consumed by the red ears. And then you basically cut that life cycle of this grub out. So then you don't have that problem anymore.
So I put some in my pond.
Red ears?
Yeah, aren't they called greens, red ear greens or something?
I don't know that. There's a whole bunch of weird names that people have for them that are the best way to say the name of a fish is to ask for the scientific name of it, because I've heard bluegills called everything from a brim to perch to black perch to orange bellies to red bellies to yeah. Anyway, there's a lot of different names for
I
it.
put some red ears in there.
Yeah.
That's, my gosh, 10 years ago, and I haven't seen any since.
Huh. Well, maybe you didn't have any reproduction on it. Could be. Maybe they're all dead.
Must have asked one.
Maybe. Could have been. Yeah. So let me look at this. It's 11:11, and I am at slide 20 of 124.
I'm going to stay longer than 12.
So what I want to do is I want you guys to give me just a couple of more minutes to get through the trophic levels that I have here, and then hopefully maybe we could do this again next year. So, and maybe I'll start at slide 30 next year and see if we can get through it.
Did you cover most of the important things?
Yes.
Yeah.
Well, and I think the biggest thing that I want you guys to take away from this is that with the right ratio of bass and bluegills in a pond, you are going to have that top-down trophic cascade on the lower ends of the food web, and those perceived problems that you have should be taken care of if you can just manipulate the bass and bluegills. That's what I want you to know, and that it's not an easy process. And I probably talk too much about that, but I think it's the most important. So we talked about zooplankton. There are planktivorous fish, bluegills. So when you have the right pond, you can create you know, these types of fisheries. Anyway,
Any preference in large and smallmouth bass in your pond?
always largemouth bass, never smallmouth bass. Because largemouth bass are not the predator that smallmouth are on bluegills. So smallmouth bass are really a different critter. The predominant prey of a smallmouth bass is what?
Crayfish?
Crayfish, number one. So so it's hardwired. That's the thing, is that smallmouth bass are hardwired to consume crayfish. They're not hardwired to consume bluegills. A largemouth bass is hardwired to consume bluegills, or prey, some prey, swimming prey species.
Should we introduce crayfish into a pond?
No. If they're there, that's fine. The bass will eat them. But I wouldn't put them in it, not unless you want to eat them.
No. Now, what is the difference between macros that I find in a running freshwater stream and the macros that I would find in a pond?
No difference. It's the same critters. Stoneflies, mayflies, caddisflies. Yeah, it's all the same. And the fish are going to use them in the same manner. So, yeah. Did you have a question back there? See where I'm at on my slides. Yes, this is another important thing. You know, we talked about fertility of your pond being very important to how much biomass you produce. Ozark ponds are very, very similar to what we see in West Virginia. You know, even though you don't think Missouri really like West Virginia, it is. It's very, very similar. There's a lot of trees, not a lot of ag that goes on, a few pastures with cattle in it. But those areas, or Ozarks in the mountains of West Virginia, at least in terms of fertility, are very similar. Now you get into Iowa, or an area that is heavily dominated by agriculture. The fertility of those soils, and particularly in the bottomlands, those are going to be very, very high, super fertile. And how many fish you take out of each one of those ponds is going to vary based on the fertility and how quickly they're going to be able to respond.
What's the effect of having cattle around your pond?
Yeah, cattle can be very problematic. It's just like instead of runoff from maybe an ag field, imagine if you took, it's just like the gray water that we were talking about from the septic system that was coming into that pond. It's exactly the same. If cows are pooping in your pond, peeing in your pond, you're going to have a lot of algae. You are, lots of algae. The algae is going to take up those nutrients.
What about the recovery rate? Like, if you had cows and now you got rid of your cows, how many years?
That's a really, really good question. And so what happens there is that if the bottom layer, that intermediate layer between the bottom of your pond and where the water is, if that's anoxic, the nitrogen and phosphorus there is tied up. It can't be utilized. That's an aerobic process. In order for nitrogen and phosphorus to be used, it has to have oxygen on it. So if there was some way that you could keep that anaerobic down there, your pond is going to come out of that problem quicker than if it's aerated. If it's aerated on the bottom, has oxygen, it's going to continue to recycle that nitrogen and phosphorus there, which relates back to the dredging thing that we talked about before. You have to get those nutrients out, otherwise it's going to be a perpetual problem.
I missed the dredging thing. What did you
Yeah,
say about dredging?
so the question was is dredging bad for a pond, or can it be beneficial? And the fact of the matter is that in those areas where you have excess sedimentation, excess runoff, excess nitrogen and phosphorus coming into your pond, sometimes it's necessary to get in there, dredge that pond out, get all of that nitrogen and phosphorus out, all of that soil sedimentation out. That way, you don't have the problem with the nitrogen and phosphorus continuing to recirculate in the pond and continue to cause problems with algae or excess plants or whatever it is.
So that's what it would be, the sign would be you'd have too much algae?
Yes.
Okay.
So you have too much algae.
I don't
Oh.
think so, but,
So it's kind of cool. You can pretty much go to a pond and look at it. And you can and I can say there's too much nitrogen and phosphorus in this pond, and there's very few bass in this pond, and all the bluegills are this big.
okay.
You could pretty much go to a pond. If it looks green, you can say, well, I know what's going on here. This one's an easy fix. So, yeah.
As a dredge, you mean?
Yeah, dredging.
Okay.
Dredging is probably the best way to get that. Now, just as we talked about, it's very expensive. And if you don't fix the problem, it's just another Band-Aid. That's all it is. You have to prevent that sedimentation, that sediment from coming into the system. If you don't, you're going to end up cussing Quinton. Like, Quinton told me it was going to work. Well, Quinton said it was just a Band-Aid. Remember that.
Is it too hard to drain it? Is that the?
No, that's a good call. Yeah, drain it. Yeah. The problem is now you got to repair the dam.
Could you evacuate the water with a pump? A big pump?
You could.
Yeah.
You know, like a septic pump.
Yes.
A big hose.
Yeah, absolutely. Drain it out. Let it all dry out. Let grass grow in there. That's the thing that we do in aquaculture, is that in these natural ponds that we grow out little fish in, every year we'll grow those fish out in them, and then we open up the floodgates, let all that water out, and then we let terrestrial vegetation grow back in there, and what it does is it sucks up all those nutrients. And the grass grows to like, in one day the grass will be like 12 feet tall. You like can't even walk through it. That's a thing. There was another point that I was going to make on that too. Can't remember. Anyway, yes sir.
When you let the terrestrial vegetation grow, do you then mow it?
Yes, get it
out?
out. Yes, because if you don't, then that's nitrogen and phosphorus you're leaving in the system. The point that I was going to make is that if you go to create a pond, you always want to have that ability to let the water out. So just as I was saying, put that PVC pipe in it. That way, when you run into a problem, all you do is you say, well, cut my losses. Now I don't have to rip up my dam. I don't have to do any of that stuff. I can just let the water out. So, problematic. We talked about geese earlier. We talked about cows. What's the problem here? Yeah, the Joneses have got to keep up with the Smiths, have got to keep up with the Parkers, right? Or whatever. Maybe it's the homeowners association. More fertilizer. That's the secret to making everything better. This is what's going on here.
No oxygen.
No sunlight.
No sunlight. No sunlight. What happens eventually is this, right? That's it. This is too much algae. Anyway.
And therefore too much nitrogen.
That's right. Exactly. This is another good one. Dissolved oxygen. You have to have oxygen in your pond. Various fishes have variable tolerances for different levels of oxygen. Something like a bluegill is going to be much more tolerant of low oxygen than bass and bluegills. The main sources of oxygen in ponds are your rooted aquatic plants, and then also algae. Algae does provide some oxygen. This is something that happens too. Everybody's like, well, I don't understand. I have all of this great aquatic vegetation in my pond, and I should have a lot of oxygen. Well, what happens at nighttime? What does a plant do at night? It consumes oxygen. So when do you think you you see the lowest dissolved oxygen readings in a pond. What time of day was that?
Sunrise.
Right before sunrise. That is the absolute lowest. I have landowners call me, they're like, Quinton, will you come out to my pond? I've got this dead fish everywhere, and they're like going crazy. And it's like 9 o'clock in the morning by the time they call. I go out to their pond and I put my dissolved oxygen probe in, it says 7, 10, 12 milligram per liter. And I'm like, oxygen is not your issue. What your issue is that in the middle of the night, while your plants were respiring, you got down to 0 milligram per liter. So now you've got an access aquatic vegetation problem. What killed all your plants was respiration. And you see that a lot. That's why it's so important to have that good balance between algae and aquatic plants. Otherwise, you kill all your fish. Of course, this is a no-brainer, right? The water quality is going to be influenced by the time of day of the season that you're talking about. In the wintertime, guess what? Our ponds are going to be colder. In the summertime, guess what? They're going to be hot. Yes, sir?
Since we're talking water quality, is the pH factor anything to worry about?
Unless you're dealing with a problem like this lady, I would say no. Yes, sir?
How do you fix strategize with the wind direction for your pond? Do you do that? Or?
You know what? That's more of an engineering question. That's an engineering question. But in South Dakota, I know you did not want north-south facing ponds. You didn't want that to happen because the wind in that state is crazy. You would eat a dam out in about a second if you had it straight north-south facing. In the wintertime, you're going to get beat up, and in the summertime, you're going to get beat up. So this is that oxygen curve that we talked about, I think. Yeah. So you can see, just as she alluded to, you can see that our oxygen. Now this is just an example, hypothetical graph, but you can see that if you have too many aquatic plants, you're going to be down in the dogouts right at sunrise. And then in the middle of the day, you're going to have plenty of oxygen.
What is the probe that you use to determine this?
There's a bunch of different ones out there. Boy Scouts are actually coming out with one that you can buy. That's like, I don't know, $20. I don't know. That's all happening now. These things are expensive. They're very expensive, thousands of dollars. But it's good. It's good to monitor the oxygen in your pond.
Does a aeration contribute anything at all to dissolved oxygen?
Sure. Yeah, it will. So what we're doing is we're actually taking the atmospheric oxygen and we're, along with a lot of other gases, because remember our atmosphere is mostly not oxygen, right? We're adding in a bunch of other atmospheric gases into the pond when we're doing that, but one of those is oxygen.
And now a pump that splashes water,
Yeah,
does that do the same
thing?
thing?
Yep. Yep. This is kind of a cool graphic and one that you might not think about. Yes, sir.
So if you're going to aerate, would you want to aerate at night?
Oh yeah, so that's the thing. I actually have a picture of how you could do that with yes at night. Yes, aeration only at night. And you see that a lot in the culture world where you're growing out fish. Yeah, here, this is the next picture. But basically, as dissolved oxygen, the tolerance for it to stay in the water is going to be greatest at lowest temperatures. And the opposite could be said, that the lowest tolerance for it to stay in solution is going to come at higher temperatures, right? Particles are moving much faster. Now this is what you were talking about, aeration. If you do have oxygen problems, this is a really cool one, right? And you know what? I work with some folks out of Mississippi. They grow a lot of catfish down there, and they always have oxygen problems. And this guy told me, he said that all of the catfish, like in this pond, were like sucked right around that because the oxygen in the rest of the pond was it was basically at zero. It's really cool. Fish like are smart, and they're going to look for places that actually have oxygen. We were growing tilapia out when I was a PhD student in Southern Illinois, and sometimes the tilapia, they would in these tanks, they wouldn't have enough oxygen, or it'd be very low. They would jump out of these tanks to try to jump into another tank, I guess, but they would end up on the floor. Anyway, which was zero oxygen for them, right? This is a paddle wheel. You see these a lot in culture facilities. And then, of course, you have something like that. All of those are all doing the same thing. Now, hopefully there's actually some problems with it. And it relates to the property of water. Water is most dense at 4 degrees Celsius. So in the winter time, that's the reason that ice floats, right? It's relating to that crystalline structure that's going on there. So that 32-degree water is at the surface, and then actually the warmer water is at the bottom. What can happen, though, with these aeration systems is that if that's drawing from the surface at 32 degrees, if you are recirculating that water, what ends up happening is that your entire water column becomes 32 degrees or close to. And then there's none of that 39-degree refugia or 4 degrees Celsius that's at the bottom. So then what you end up doing is you end up supercooling the pond, making it too cold. Now, what happens? So you have to move where your aeration system is. In the wintertime, if you have it at the surface, you're going to supercool everything. In the summertime, if you have it down below the thermocline, what you're going to do is you're going to recirculate a whole bunch of anoxic water because it's below the thermocline. So you have to be very mindful of where that aeration system is with respect to the time of year. Stratification is a big thing. I'm not going to talk about that much. I think we've hit this. Low oxygen at the bottom. If you have your aeration system at the bottom, you're going to be spitting that, low oxygen water throughout everywhere, right? And then that's not going to be good. This is actually pretty cool, and I think this kind of relates into basically how the properties of water work. So in the summer, we have something called the epilimnion. It's going to be the warmest water, but it's going to be full of oxygen. Then we have the thermocline, which is going to be this transitionary period between the epilimnion and the hypolimnion. That's spelled wrong. Anyway, this is going to be cold water, but there's going to be very little oxygen. What happens, though, as we transition from summer to fall, is that hypolimnion, because of the properties of water and the denseness, as it warms up, it actually starts to float. Then as it floats, you're taking all of that anoxic water to the surface. If there's not enough aeration going on, guess what happens to all your fish?
Dead.
Yeah, they're dead. As we transition from the spring, as we transition from fall to winter to spring, we see those same kind of processes going on. Water is, again, the coldest at the surface, most dense at 4 degrees or 39 degrees F. Again, we turn that water over, we again in the spring, and we start this whole process over.
This is typical of a pond or a lake.
Mm-hmm.
What about a river or a stream where you have different depths of water?
Right.
Something similar?
Well, it can, if you have deep enough water in the stream, particularly, where you see this is particularly in those, in the pool areas. And especially if there's not enough mixing, there's not enough water going into that pool.
So is there any benefit to taking the temperature of your body of water?
Yeah, I mean, I think so.
Depth?
Sure, yeah, so the way that you can identify where your thermocline is at is you basically take a probe and you drop it down, and for every 1 meter you go down, if you change 1 degree C, that's where your thermocline is at. This is going to be fairly homogeneous in terms of temperature, and then this is going to be a stark change from this top part, and then this is going to be a stark change from that. You're going to start to see that 1 meter of water depth change to 1 degree Celsius change is going to be much less exaggerated once you get to the hypomnemia that's felt on.
So the fish, if they hit the thermocline, they go to the surface.
Yeah, so what? This is going to have some oxygen in it, and it's going to be relatively cool. What we think, we've actually put transmitters in fish. This water, sometimes this gets really hot. So what we think, now this is speculation, we have these like tilt tags. And what we think that the fish do, at least at some points during the year, is that they'll have their body positioned down in that cooler water, particularly where their gut's at, so they can digest all the food that's there, not use up a bunch of, it's not a metabolic heavy process because it's cooler. And then their head is actually above the thermocline into the epilimnion where they're breathing the oxygen. Wild.
If the pond is healthy, you don't want to mess with the anoxic layer?
No, don't touch it. Leave it alone.
So you'd only aerate from the top layer?
Yes. Yep. Yeah, you start bringing this up, and you're gonna have problems here. Yeah, don't do that. All right. This is anybody? I'm sure you all have seen brown ponds. That's related to turbidity, and it's caused by a bunch of different factors. But one of the big ones is that it's going to reduce the lifespan of your pond, and the reason for that is because again it's that sedimentation and the need for dredging. But again, dredging just being a band-aid. You need to prevent whatever that turbidity is from coming into your pond, whatever excess sedimentation that is. The other thing that it will do is that largemouth bass are a side-feeding predator, and if you're trying to maintain a proper ratio of bass to bluegills, you can end up causing an imbalance just simply because the turbidity of the pond is such a problematic factor. It relates back to your comment about what percent aquatic vegetation do you have. This would be like 100% aquatic vegetation coverage because they can't see to eat the prey. Yes.
But a brown pond, is it brown year round or just? Because my pond looked.
Gets brown in the springtime.
Yeah.
And then in the summer and the fall, it's not.
Mm-hmm.
Yeah. So that's you probably have a runoff problem in the spring, and then in the summer and the fall, the rains are probably not big enough to cause that issue.
So it's not. I guess in a direct sense turbidity.
Yeah.
It is.
It is still turbidity. It's all turbidity. When it turns brown, that's turbidity. Your problem is just not a persistent problem. You're probably not low enough. I think if you were at a lower altitude, lower elevation, then you might see more brown more often, which I think makes sense. So everything's got to end up at the bottom, right? There are some fish that can cause problems with turbidity. One of those being bullheads. Those can be problematic, and even channel catfish at really high densities, and that's why I suggested 25 per acre. Common carp, Again, this is the pig. If you put lipstick on it, then it would be a koi, right? There were some other pictures of geese up there, all of those things. All of those guys can, they can cause, turbidity issues in your pond. There are ways to determine whether or not your pond is actually turbid from runoff or turbid from a chemical imbalance that's going on in the system. So what you should do is the next time that it gets turbid, which I'm assuming that this will be just like what we were saying, it is a runoff issue. If you put a jar of that brown water in, screw the lid on real tight, and then set it on your porch for a week. If all of that sediment comes out, the water is clear at the end, then that means that you just have a runoff issue. If it doesn't, if it stays brown, then the chemical concentrations in there, or the ions that are actually responsible for keeping that turbidity in suspension, you need something to take those ions and make them heavier and go down to the bottom. And in that case, we would use hay treatment or gypsum, which actually makes those ions heavier, the particles heavier, and it all sinks down to the bottom of the unit.
What is hay treatment?
Like taking a bale of hay, throwing it in your pond.
Really?
Yeah. Yep.
But
Makes
it
those
stays down or
ions
keep it
heavier.
at the edge.
What's that?
Do you keep it at the perimeter? Or?
I would, again, all we're trying to do is trying to increase the amount of surface area that's present, or that the water has access to, so you wouldn't want to put it in the shallows. I'd put it out in the middle. Let it float around. Put as many of them, in a 1 acre pond, we would take those big round bales and throw those in.
You mean solid as they are, not
Yeah.
open them?
Nope, don't do anything. Just put it out there. Let it bob around.
Oh.
But you got to do the jar test first. You don't want to do that. What would happen if you put a whole bale of hay in there and you didn't have and it would all settle out? It's just like the question that he asked. That, once you allow that terrestrial vegetation to grow up, you want to cut it, but you also want to pull it out, do something with it, not let it sit in the pond. That is a ton of nitrogen and phosphorus to be put in that pond if this is really not an issue. Oh, yes, sir.
I'm just a little confused. So you're fighting the hay bales fight turbidity
Because
that is chemically induced?
yes. Yeah, and it could be due to something in the watershed that's causing those ions to be able to remain in suspension. And then the hay is actually acting, its chemical properties are doing some chemical reaction to make those ions heavier and settle out.
And do
Anyway.
you pull the hay out afterwards or just let it stay?
I mean, you could, but I think you'd be hard pressed to pull that out of there.
Yeah.
That's gonna be a heavy beast.
What was the alternative to the hay treatment? Oh, gypsum.
Gypsum,
Sorry.
yeah. Yeah, this makes sense too, right? If you add hay bales to your pond, that's going to be an aerobic process. It's going to be decomposing. So during that decomposition process, you're going to be using up dissolved oxygen. I really want to show you guys one other thing. Oh, this is important though. We talk a lot about that riparian buffer zone, or whatever it is, the area around the pond. We really need to build this up. This all needs to be built up, because if it's not, then all of that nitrogen or phosphorus is going to hit the landscape and come directly into that pond. So, yeah.
What's this about riprap?
Riprap? What is riprap?
Well, I don't. We had some put in when
Oh,
we
yeah.
constructed it.
Uh-huh.
That's good.
Yeah, I mean, it's not. I don't like the looks of it, but it does. It stabilizes the bank and prevents any erosion from happening. But above this, there still needs to be a vegetation growing, because this is not really acting as a filter to remove any of that nitrogen or phosphorus. Rocks don't like nitrogen or phosphorus. Plants do.
It's not as limestone, right?
Yeah.
So is calcium introduced?
Yeah, mean, it's not doing anything bad, that's for sure.
Is it gypsum, calcium, form of calcium?
Yep, it is. Now this one, this might not be, it might not be the same thing that you're talking about. Yeah, anyway. We're not going to talk about that.
So if you use the hay bales
Uh-huh.
to fight,
Uh-huh.
how many what's the formula, how many hay bales per, say,
Per acre.
surface acre?
I would do one big hay bale per acre, or maybe two, even three small bales. We always go on the conservative side.
When you
People
say hay, you're talking about the roll.
Yeah, yeah. We typically tell people only do 1 or 2 per acre of the square bales, but I say do it up if you're going to do it. Put a big one in it. But make sure first off that you have that problem. Make sure that it's not just it's the digest. Yeah. So this is it. We talked about this. I want to get to the calculations of how you might look at balance in a pond. Yeah, see, these are the ones that, there's one here, don't stock these. See these two? These are weird. You don't know what you're going to end up with. That's a good one, and that's your fish that you were talking about. These are really good ones. Remember, they'll eat the snails that will whack that life cycle of the grubs in half. Again, other ones that you shouldn't stock: smallmouth, walleyes, flatheads, blue catfish. Don't do those. Now, in special situations, especially if you want to put more time and effort into your pond than just keeping this natural system, you can do some of those other predators. But if you're not going to be investing a lot of time, I would suggest not doing that. Some other prey species that people put in their ponds: gizzard shad, or gizzard shad's a big one, and then minnows. Again, don't do those. Just use bass and bluegills. Again, another no-no. This is just a good example, and I'm very much a big proponent of going out there and harvesting fish out of your pond. You understand what's going on in your pond, and you're providing a good protein source that's, I don't know, not the not so good fish from the grocery store. It's pretty amazing how many fish that you can harvest after the fish have had a chance to spawn. Bluegills, you can harvest about 200 of those. If you had 300 of them in your pond, you could harvest about 200 of them in a year. Now you got to let them spawn once. So then there's, and why would it be good to start harvesting some of those bluegills?
Keep up your zooplankton.
Right, exactly. They're part of the food chain. And if you don't, eventually what's going to happen to all those bluegills is that they're all going to become the same size because there's too many of them. It's okay to harvest them. Largemouth bass, you're harvesting about 20 or 30% of that every year, right? Bluegills, you can harvest maybe up to 35, 40% of the population every year. Yes?
What time of year do they spawn?
Bluegills are going to spawn all summer long. Typically start beginning of June, end of May, beginning of June, and then they may spawn until August. The largemouth bass, they're going to be a May and June spawner, and then they're going to be done. Bluegills have a protracted reproduction life history strategy, and what that means is that they're going to spawn at a very long window throughout the year, that way that they ensure the persistence of their individual species. So if the conditions were poor early on in the year, They spawn, but none of the larvae survived. Well, there's going to be multiple bouts of spawning that are going to occur at later points. Bass don't do that. We always talk about balance, and I think that this is a very good graphic. And so we don't want this to happen, because that's going to be that sign that we have super green water, all of our fish are dead, you know, whatever that bad thing is. And over here is that we have a picture of your pond, you know, a pretty pond with a good aquatic vegetation, and that little kid holding up the bass like he's strangling, right? When we talk about balance, we want to make sure that we have a range of sizes of our bass and our bluegill that are in the pond. What this might indicate is that maybe this is a 4-year-old fish, this is a 3-year-old fish, that's a 2-year-old fish, this is a 1-year-old fish. Now when we see that, maybe we've only stocked one time, we go out there 5 years later and we're seeing this, that's a really good sign that our pond is doing what it's supposed to be doing. It's doing its natural thing. And then also, it's nice to see all these beautiful bluegills taken on the fly out of a balanced pond.
Now you said, was it channel cat? You said it depends.
On how many to stock?
Yeah.
Yeah, 25 per acre.
Yield. Those were yields, right?
What do you mean?
How many harvests?
Harvesting.
Oh, on catfish it depends. How many ever you harvest, you have to put those back in because they're not going to reproduce.
Unless you have the boxes. Or
Unless you have boxes, right? This is what we've already talked about this, but this is basically that food pyramid that you guys saw earlier, but in birds, trophic ecology.
There's no set it and forget it kind of pond. You have to.
No, there is, but it's still not completely set it and forget it. It's set it, use it, but don't worry about it.
You got to harvest some fish.
Yeah, you should. You should harvest some fish. You should be a part of it. You know, it's like you know, I had a farmer in Kansas that was complaining to me like, well, but I don't want to have to go out there and do all this stuff to it. That's like, now wait a minute. You spend the entire month of March planting, and then you go back in September and you harvest all of that corn and wheat, whatever you plant. It's the same thing. It's the same idea. You do have to, even though he doesn't really have to worry about it between March and September, he does. It's the same way with a pond. There's going to be very little input that he's going to have during that time. But you have to be mindful of your crops. And that's the way that ponds are too. You have to be mindful of your crops, what's going on.
Invite a friend.
Yeah, invite a friend, right, exactly. Go fishing. Bring an adult beverage. Cook some hot dog, whatever. This is what I was talking about earlier. Is something in the ecological world we term carrying capacity. And I have 9 minutes. I would love to have a bunch more time with you guys, but this is another big concept that you need to know. And typically the way that we think about our ponds is that we can have somewhere between 300 to 500 pounds of biomass per acre of system, or per acre of water, surface acre. Now if you add water or you add oxygen, or not water, if you add oxygen or add food, you can actually beef that number up. But because this space is limiting, you got to have a proper balance of your predator and your prey. You want to have this continual production of predator and prey, adequate prey for all your trophic levels. And these balanced ponds, just as I showed you in that graphic, they have a high biomass at those lower trophic levels. And as you move up, it progressively gets less. Unbalanced ponds, you typically see a bunch of really small bass, but that can be good too, because what it does is it creates big bluegills. which makes sense, right? The opposite could be said. If you have a bunch of little bluegills, you're not going to have very many bass, but the bass that are there, they're going to be really big. What we're shooting for is something that would be in the middle. This is a good example. This is that imbalanced pond. You have a bunch of really small bass, but the bluegills that are there are all giants. This is the example on the other way, right? Too many small bluegills, few big bass. I want to show you guys how you can calculate this. There we go. So what we suggest people doing is that so we're not basing our hypotheses on supposition. We're basing them on science. We suggest that people keep a log when they go fishing of what species they caught and of what sizes. And then when you're armed with that information, then you can make better decisions on what might need to happen in the pond. If you go in there and all you catch are really small bass, well, that's going to mean something to you as the manager of that pond. Just the same as if you only go in there and you catch a bunch of small bluegills. But if you actually have record of that and keeping track of it, that's going to allow you to be able to speak with the scientific knowledge that you need to be able to go and manage these populations. Yes, sir.
You gave us good recommendations on what varieties to stock and when to stock. Can you give us any recommendations on what and when and how much to feed them after you stock them?
You don't need to feed them at all.
That's what I want to know.
Yep, you don't need to feed them at all.
How do I keep the big ones from eating the little ones?
You don't. You want them to do that. Yep. And if you keep that ratio right, then you don't have to do that. If you're gonna, now that being said,
What about the catfish?
now every catfish that you harvest, you got to put another one in because they're not going to reproduce.
Feed them?
You don't have to.
Okay.
Now I did when I was a little kid. There was a guy that had a pond, and he could here kitties. He'd come onto his dock, and I always thought, whoa, this guy can talk to his fish. Which that's not really what it was. Now knowing. He'd stomp on the deck 3 times, or whatever, and then the catfish knew to come up to the surface. But he would sit there and feed them dog food. It was like the coolest thing ever. Hot dogs, whatever. You can do that.
The grandkids.
Yeah, they do. I did, This gives you an example of what it might look like. This person did a really good job of keeping track of their catches. And so when you see that shape that looks like a bell, that's usually a good thing, right? Bell-shaped distributions are a good thing in science and all those other fancy subjects, right? The same goes for our bluegills. Again, we see another bell. Now, what happens if you didn't see bells? Then you've got problems. But this is the way that you can kind of figure it out. Now we can even get a little bit more fancy. And that's what Dr. Swingle did. Is that he went out into a whole bunch of ponds in the southeast, and he drained them all, and he figured out what ratio of predator and prey you needed in terms of weight. He did something called the F to C ratio, and what you want is somewhere between 3 and 6 pounds of forage or bluegills to every 1 pound of predator or largemouth bass. If it's below that, the F to C ratio is 1-to-1. You have way too many carnivores that are going to be there, and that's going to be unbalanced. You're going to probably have a bunch of blue, or not very many bluegills, but the ones that are there are going to be really big. If it's over 6, 10, 12, 13, then you're going to have a bunch of little bitty potato chip bluegills, very few bass, but the bass that are going to be there are going to be very big. If you're in this 3 to 6 range, then you're going to have both average size bass and average size bluegills. Probably very similar to those two bell-shaped distributions that I showed you.
So that's 3 to 6, 3 to 6, 4-H to carnival.
4-H to carnivore, yep.
3 to 6 pounds of bluegills to
1 pound of bass, right. Yep. This is how they did it in the old days. They drained the ponds. That was the base end of the research. This is the best way. Sample the pond. And what you do is you keep track of that. How much weight did I catch of bluegills? How much weight did I catch of bass?
So it's not catch and release, right?
It could be. Doesn't have to be. You can catch them and eat them. You could do that. It's best to use something like worms, something that's going to catch both bluegills and largemouth bass on a bobber. That's my favorite. That's my favorite one to catch, or favorite one to use. Weight of fish captured per unit of time or length. So let's say that Steve and I went out to Steve's pond and we fished for 2 hours. And in those 2 hours, we caught 4 pounds of bass and we caught 12 pounds of bluegills. What is our F to C ratio?
3 to 1.
3 to 1. So our pond is in balance. Now, when we looked at that pond, it very much looked like yours. It was beautiful. It's perfect. There's not too much algae. The zooplankton was doing its thing. My point is, with all of this at the end, is that if you can go out there and you can get a representative sample of your fish population, and that ratio is somewhere between 3 and 6, I'd almost bet you $1 or a Coke that you don't have problems within that basin. The only time that those ratios get out of whack is when there's something else in the system that's causing problems. Could be excess runoff, could be cows, could be ag, could be, X, Y, and Z. You're mowing all the way up to the bank. You put grass carp in there. You stocked minnows. You put blue dye in your pond. I'm sorry to pick on you. Yeah. Anyway, I am at slide 71 of 124, and then I think we are cashed out at 12 o'clock. So, I want to first say thank you for your time and attention. It's been wonderful. Hopefully you got something out of this. If you didn't, sorry. If you did, good. And hopefully I'll get to see you guys maybe again next year, and we can start at slide 72. All right.